Coming up on Destination Tomorrow, NASA is developing new catalytic converters that will greatly reduce the pollution coming from our automobiles. Plus, new technologies will help pilots avoid turbulence in the skies and help lower injuries aboard commercial aircraft. And we take a look back at the successes of the TDT, or Transonic Dynamics Wind Tunnel. Our own Johnny Alonso finds out the secret behind lasers and how they work. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonegal.
And I'm Kera O'Bryon. Welcome to Destination Tomorrow.
This program will uncover how past, present, and future research is creating today's knowledge to answer the questions and solve the challenges of tomorrow.
A unique experiment mounted on the exterior of the International Space Station called MISSY, or the Materials International Space Station Experiment, will test the durability of hundreds of samples, ranging from lubricants and paints to solar cell technologies. The samples will be subjected to the harsh effects of the space environment 220 miles above the Earth.
By examining how the samples fare in space, researchers seek new insight into developing materials for future spacecraft, as well as making materials last longer on Earth. MISSY will be retrieved and brought back to Earth on the space shuttle. The samples will be returned to researchers and analyzed to determine which materials are the most durable and suitable for tomorrow's spacecraft.
James Jones spoke with Dr. Bill Kynard about this fascinating experiment.
The International Space Station is the largest and most complex international scientific mission in history. With this orbiting laboratory, there will not only be new advances in space technology, but a chance for all types of different scientific fields to have new theories tested and experiments completed in space environments. And not all of these experiments will be tested inside the station. NASA is conducting experiments outside the International Space Station with a new project called MISSY, or the Materials International Space Station Experiment. The first experiment mounted externally on the International Space Station, MISSY will investigate the effects of long-term exposure of materials to the harsh space environment. MISSY will also evaluate materials currently being used and those planned for use in future space missions. I spoke with Dr. Bill Kynard at NASA Langley Research Center to find out more.
MISSY is a technique to utilize the space station to do space exposure experiments. Of course, the name says it's a Materials International Space Station experiment, but it's a lot more than that. MISSY is not one experiment, but actually it's a collection of about over 1,000 different experiments. MISSY involves some passive experiment containers that have been developed here at the Langley Research Center. And these are basically small suitcases. We can put test specimens inside these suitcases, close them up, and then we can transport them to space by the shuttle, take them out during an extravehicular exercise. We'll open the suitcases up to expose the specimens on the inside, and they clamp them to handrails on the space station.
Bill, you mentioned specimens. What sort of specimens are we talking about?
Sections of material, small pieces of material that we can expose in space that are large enough to let us understand how the space environment is going to affect them. Or in other cases, some of the specimens are components. Solar cells, for example, or electrical switches, parts of a fiber optic cable that might be used on a spacecraft. We are testing composite materials and ceramics and polymers that might be used to construct more conventional spacecraft. We don't have to modify the space station to accommodate these experiments. There are lots of handholds all around the station, and we can locate these experiments in various places. So it's a very economical mode to utilize the space station for some very critical type testing.
MISSY is a passive experiment, which means that aside from deployment and retrieval, no other interaction is involved. The two carriers will be retrieved approximately 1 year after deployment and returned to Earth on a later shuttle flight. Bill, why does NASA feel the need to do these experiments in outer space as opposed to here on Earth?
I think everyone is aware of the contributions we get every day from satellites in space. But I don't think people are aware of the fact that the environment these satellites have to operate in to give us this information every day is an extremely hostile one. Space is composed of harsh vacuum. This vacuum can change the composition of materials that spacecraft are made from, and this changes the properties of these materials. Spacecraft are exposed to unshielded, harsh ultraviolet radiation. This radiation can very quickly darken and embrittle most of the plastics that we use every day on Earth. We cannot simulate these environments in the laboratory adequately to do testing to establish whether materials can function in space.
So what happens to the materials when they come back to Earth?
We get them back, we'll bring them into a clean room such as this, and the investigators will look at it, and the first thing they'll do is establish whether or not the material survived. Was it completely destroyed by the exposure in space? If it survived the space exposure, then they will do testing to see if it still has the unique properties that are needed for future space missions, and see whether or not that it can function and deliver the data over the extended mission that's required. Hopefully with MISSY we get adequate data on these materials so that the designers can select the right materials and be confident that the spacecraft they design and build will function.
The MISSY experiment will allow researchers to not only discover the strength and durability of the retrieved samples, but also gain insight that will help them design and manufacture new materials that will last longer on Earth, in space, and other planets. Coming up, NASA has developed a new catalytic converter that will help dramatically reduce pollution emitted by automobiles. But first, did you know that the MISSY experiment is not the only passive experiment being tested on the International Space Station? A new experiment called the Phantom Torso is being used to test the effects of radiation on astronauts. The torso consists of hundreds of radiation monitoring devices which are embedded into artificial skin, real bone, and special plastic organs that represent the density of human tissue.
Americans have always had a love affair with the automobile. With our vast open spaces, the automobile has provided us with convenient, relatively inexpensive transportation. But unfortunately, this convenience comes with a price: pollution. In recent years, the government has mandated new laws requiring cars to run cleaner. In an effort to do this, car manufacturers began installing new pollution-reducing devices, like the catalytic converter. Although these converters have helped to reduce pollution, they are still not as effective as they could be. Now, researchers at NASA have designed and built a new type of catalytic converter to help reduce pollution even further. Using technology first designed for space, these new converters may prove to be much more efficient than current catalytic converters. Tonya St. Romain finds out more.
At one time in the U.S., air pollution created by cars had almost reached epidemic proportions, especially in large cities. To help reduce the pollution, clean air laws were created, driving car manufacturers to reduce the amounts of pollution produced by cars. One of the devices developed to help reduce these pollutants was the catalytic converter. Through a chemical process, this ingenious device helps convert exhaust gases into less harmful emissions, causing less pollution. Even though the catalytic converter has been very successful in reducing pollution, one of its weaknesses is that it must reach a high temperature before the chemical conversion can take place. So while the catalytic converter is still cold, a substantial amount of pollution still enters the atmosphere. To help solve this problem, researchers at NASA have invented a new type of catalytic converter called the low-temperature oxidation catalyst, which begins working as soon as the car is started, greatly reducing the amount of pollution that reaches the atmosphere and making the air we breathe much cleaner. I spoke to Dr. Jeff Jordan at the Advanced Measurement and Diagnostics branch to find out more.
The conventional catalysts have actually relied very heavily on so-called precious metals such as platinum and palladium to do much of the work. Unfortunately, these systems don't begin to convert pollutants into less toxic gases until they get very hot. So when you start your car up every day, particularly when it's cold outside, you are effectively emitting all of the pollutants from your tailpipe directly into the environment. Now, if you think of that happening billions of times each day, that's a lot of pollution.
A typical car produces harmful pollutants like carbon monoxide, hydrocarbons, and nitrogen oxide, which when released into the air are very destructive pollutants. To help reduce the harmful effects of these pollutants, most modern cars are equipped with catalytic converters, which actually convert these pollutant gases into less harmful gases. It does this by chemically changing the composition of the noxious gases into less harmful gases. Catalytic converters are generally ceramic structures coated with a precious metal substance like platinum or palladium. Most catalytic converters are encased inside a metal housing that's mounted along your car's exhaust system. When the harmful gases come in contact with the precious metal, the chemical reaction that occurs in the catalyst actually changes the composition of the gases, causing fewer pollutants to enter the atmosphere. In order for this chemical process to take place, the catalytic converters must be heated to a high temperature. Unfortunately, when you start your car, the catalytic converter's cold, doing almost nothing to reduce the pollution in your exhaust, allowing huge amounts of pollutants to contaminate the air. This is where the NASA catalytic converter comes in. NASA researchers have created a new chemical process which can actually convert the pollutant gases into less noxious gases almost immediately, even while the catalytic converter is cold. This dramatically reduces the amount of harmful pollutants which are distributed into the atmosphere. Many believe that this new device could cut pollutant gases by as much as 30%, making the air we breathe much cleaner.
The NASA catalyst has some unique qualities and characteristics. Of course, its genesis was for space-based carbon dioxide laser systems. So it was originally developed to operate in the cold vacuum of space. As such, when we bring it down to a ground-based, an Earth application, we see that it is much more effective in eliminating pollutants under what we call cold start efficiency, or when you first start your car. The NASA catalyst starts to convert pollutant gases to environmentally friendly gases almost immediately because of its low temperature capability.
So what other applications can this kind of technology be used for?
Our group is working closely with several external companies to develop products for a wide variety of applications that include gas sensors, like the carbon monoxide sensor in your house, indoor air purifiers, and even gas masks.
Jeff, for you, what is the most satisfying thing about doing this type of research?
Most think of the NASA mission in terms of exploring the universe or our own planet, but NASA's success is also judged largely on the extent to which our research can improve the quality of life for our customer, the American people. The low-temperature oxidation catalyst is a perfect example of a space-based technology that's being transitioned in order to improve the quality of life for all Americans. So the next time you have your catalytic converter in your car replaced or buy a new car, there's a very good possibility that a little bit of NASA space technology is riding along with you to improve the air.
By the mid-1950s, with the advent of relatively thin aircraft wings, a new and dangerous phenomenon related to wing flexibility was being encountered. Many pilots were experiencing severe wing oscillations called flutter during flight, which threatened the safety of the aircraft. The need to better understand this new phenomenon led to the development of the TDT, or Transonic Dynamics Tunnel at NASA Langley. This new wind tunnel needed to not only test the elastic properties of aircraft, but also test a host of other aerodynamic situations in an effort to save lives. Early airplanes were built with materials that could easily withstand the relatively low speeds that aircraft were flying at that time. But as aircraft began using thinner wings with more powerful engines for high-speed flight, pilots began reporting encounters with flutter in some aircraft. There was very little data to explain this phenomenon at transonic speeds, so researchers at NASA decided to build a unique wind tunnel which could help answer some of the questions about this new phenomenon. This is where the idea for the TDT was born. The decision was made to convert the 19-foot pressure tunnel into the new, more modern TDT. Early in 1960, after years of intensive design and calibration, the world's first aeroelastic testing tunnel was ready for service. Unfortunately, fate had already selected the TDT's first occupant, the Lockheed Electra. After 2 fatal crashes of the Lockheed Electra, investigators found that in both crashes, the aircraft's wings had separated from the body of the plane due to violent flutter. A 1/8 scale model of the Electra, complete with rotating propellers, was quickly readied for the TDT's test chamber. As testing began, engineers found that the Electra's structural safety margins far exceeded its requirements. However, as the stiffness of the engine mounts were reduced, the torque of the engine-propeller combination led to a wobbling motion. The wrenching of the engine reinforced the wing oscillations until